Let's take a look at another quick example of how we can find the derivative of f of x when f of x is a polynomial. So a quick review, we're going to use the power rule, which we've learned from before, where if I take the derivative of x to some power, that power gets multiplied to the front with whatever coefficient might already be there, and then we subtract 1 from the power. So there's a quick little example there that if we had x to the 5th power, we bring down 5 times the existing coefficient times x to the 4th power, right? So we subtract 1 from 5 and we arrive at 4. The other recap is that if we take the derivative of a constant, let's say any number that does not have a variable, the derivative of a constant is equal to 0. All right, so we're going to apply those in order to find the derivative here of f of x. So if we want f prime of x, we go ahead and we can start by that first term has a power of 7. So that means that that's going to be what I multiply to my existing coefficient of -6. That's going to give us negative 42x. And then from 7, we subtract 1. So that gives us x to the 6th power. All right, we do that again with the next term. Here I have a power of 2. So I would bring that and multiply to the existing coefficient of positive 2. So that's going to give us 4x. And then 2 minus 1 would give us x to the power of 1. So we don't really need to write the 1 though, it's just 4x. And then finally here, we're going to take the derivative of 68. Since 68 is a constant, a value that has no variable, this just ends up being a 0. So the derivative of 68 is 0. Therefore, by adding 0, that does not change our existing derivative. So we could say f prime of x will be negative 42x to the 6th plus 4x.